Good morning, everyone. Delighted to be here with you today. Always sorting out clickers. So I wanted to talk to you about the College of Computing, which we've been building since just before the COVID pandemic. So the college was announced when we had a sort of kickoff in 2019 when I was still at Cornell Tech in February. Got here in August, did a bunch of planning following on to the initial planning that had been done under the leadership of Anantha Chandrakasan, the Dean of Engineering, and Marty Schmidt, our former provost. And then in January of 2020, we put the new college in place, and we all know what happened about 2 months after that. So the college and most of the faculty and people that you'll be hearing from today are affiliated with the College of Computing. The college is really looking at computing broadly, and in particular, the fact that it's becoming part of how almost every academic discipline, and in fact many areas beyond academia, actually conceptualize what they're doing. Computing's moving from being a tool to being something that really changes the way that we look at problems. But this has been really overwhelming the research and education pathways. And when I'm out meeting with people in industry, most of what I hear about is how do you produce more talent for us in CS and AI? So there's skyrocketing demand, particularly for CS and AI expertise, but for other areas of computing more broadly. The advances that are happening in computing are often not accessible to other fields. So if you think about, say, mathematics, which many disciplines at MIT depend on a lot, the math that people are depending on often was invented 50, 75, 100, 150 years ago. The computing, especially machine learning that people are depending on or should be depending on, has been invented sometimes months ago. And so that problem of how do you diffuse that information across is very different. And then the fact that computing is so broadly applicable and so rapidly deployed across a wide range of industries means we really have to understand the implications of things earlier on in the development process. So the college is doing three things. We're leading the rapid development of computing at MIT across the institute with a focus on CS and AI because of their huge importance, but it's computing broadly. We're infusing computing with other disciplines, and that word infusion is very carefully chosen and deliberate. It's not computing in service of another discipline. It's really the intellectual engagement between other areas. And Raphael Reif, our president, coined the phrase bilingual education, which I think on the education front is a very good way of thinking about this, people who speak languages of a discipline and computing. And then we have programs that help people focus on social and ethical considerations in computing early on and throughout their education and through design process. So the College of Computing brings together every unit at MIT that's primarily computing focused. So on the academic front, there's EECS, Operations Research Center, Institute for Data Systems and Society, which has statistics and data science and the technology policy program in it, and the Center for Computational Science and Engineering. Some of these are co-managed between the college and one of the schools. So EECS remains in the School of Engineering and is co-managed there, and Operations Research Center remains in Sloan. But they're all brought together, and the heads of these units now meet regularly as part of the College of Computing. And on the research front, the research labs and centers that are primarily computing focused, CSAIL, MIT IBM Watson AI Lab, the Lab for Information Decision Systems, Quest for Intelligence, and the Jameel Clinic, which focuses on AI and health. And again, MIT IBM is also jointly in the School of Engineering. So the College of Computing really provides sort of the single-threaded leadership across MIT rather than being another school. So the other thing I wanted to point out, because I think it's very important, not just in academia, although it's more evident in academia, is that things are evolving so rapidly that what used to be conventionally traditional disciplines that were separated from one another are now overlapping and sort of banging into each other, and the boundaries are moving around. So if you look at electrical engineering, computer science, we have this new area called artificial intelligence and decision making, operations research, technology policy, computational science and engineering, et cetera. These things are overlapping and the boundaries are not clear anymore. And so the kind of coordination that the college is doing with these areas is one, and it's not that these are indistinguishable from each other, sort of, core AI or core EE or core CS are still distinct from one another, but there are not clear boundaries between these anymore. And so the college is managing those changes. The college is not just about leadership of existing things at MIT around computing. It's also about two very important cross-cutting areas that bring together activities across the institute. So one is the Common Ground for Computing Education, and the other is what we call CERC, or Social and Ethical Responsibilities of Computing. The Common Ground brings together multiple disciplines in creating and offering classes and curricula. Universities are very good at developing excellent programs in a particular disciplinary area, but when you need to bring the perspectives of multiple disciplines together, there's not really a structure that supports that in academia. So in the area of computing, or as I mentioned before, because computing is being infused with so many disciplines, it's important that we be developing and offering a lot of these classes aimed at bilinguals. The Common Ground is there to help support that. And then CERC is aimed both on the research and the teaching front at helping people consider the social and ethical and other perspectives in their work and looking at responsible deployment of computing technologies. And I'll talk about both of these in a little more detail in a moment. So just sort of diagrammatically, this breadth and depth across MIT. So the three things on the right are just a reminder of what I said a moment ago about what the college is doing, the sort of three legs of the stool. And the college is cross-cutting. Oops, this got copied someplace. Font got mangled a little bit. But so CERC, the Common Ground, the AI Policy Forum that I'll touch on, and then all the units that I mentioned, all cut across the existing 5 schools at MIT. And matrix management is not something universities normally do. So there are also cross-cutting research areas, and these are critical as well. So computing in life, and there are a number of them, but 2 I just wanted to highlight. One around computing in the life sciences, where we have the Jameel Clinic, focused on translation of AI and machine learning in healthcare out to clinical practice. At the Broad Institute, there's the new Schmidt Center, which is co-led by Caroline Euler, who's a EECS and IDSS faculty member. And we also have connections with the Reagan Institute. So a lot of what we're doing in machine learning and AI in health is aimed at practice all the way out to clinics or to real biomedical research. On AI, we're also looking on an AI at the connections to natural intelligence, and the quest for intelligence really looks at artificial and natural intelligence as interlocking aspects of the same grand challenge. And when you think about what's been happening in machine learning these days, it's relatively disconnected from what's going on in cognitive and neuroscience. Maybe, neural networks were very loosely motivated by neural structures in the early days, but there's not much connection there these days. This is deeply connecting the cognitive and neuroscience with sort of future AI and machine learning work. I also wanted to talk about broadening representation in computing. It's very important in the academic world and in industry that we continue to improve diversity in computing. I just wanted to talk about 2 programs. We have a lot of programs going on in the college. These are both ones that are quite recent, so I thought it would be good to highlight them. One's called Thriving Stars in Electrical Engineering and Computer Science, and it's aimed at increasing gender representation among graduate students in computing and information technologies, which means that it's starting at the undergraduate level, because by the time they're in graduate school, you already have the mix of students that you have. And this EECS 10 or 15 years ago started something called Rising Stars, which was graduate students and aimed at helping them get faculty positions, women. And in fact, now there's a huge change that we see at EECS and MIT and elsewhere. Recent EECS faculty hiring is about 40% women now, up from about 20% at the time that the Rising Stars program was started. And Thriving Stars is now one step further back in the pipeline at the undergraduate level, looking to bring women and other underrepresented genders into graduate school in computing. The other program is really trying to broaden expertise and excellence in computing, particularly in AI in this case, at other institutions. It's not just the MITs and other institutions of MIT's academic caliber and research focus that train a lot of students these days. It's schools at all levels. And so Breakthrough Tech is something that we're doing here in the Boston region with a whole array of schools in Boston that have computer science programs, but don't have the same kind of AI expertise and ability to both help their students learn more in AI, but also to connect them more to companies. So we're also leaning heavily on MIT's very strong relationships beyond the institute to applications in the corporate world. And so there's a skills-based curriculum here that in this program. There are industry projects as part of the program, and mentoring and career coaching for these young women. So these are not MIT students at the undergraduate level. They're also not, Harvard or BU or other students. Basically, any university in the Boston area that attracts students internationally is probably not on the list of places that we're working with. These are the places that are really educating more local and regional students that often have less access, both to advanced AI education, but also to ties with the companies that people like you work at. So this is something that I'm very excited about, and it sort of ties back to my Cornell Tech days, where we spent a lot of time in New York City broadening participation in computing by working with a broader range of institutions. So, the heart of an academic institution is its faculty and its students. So I wanted to talk a little bit about faculty hiring, because we've been doing a lot of it. So part of what happened in the creation of the College of Computing was to grow the MIT faculty by about 5%. So this all was part of the planning before I got here. So 50 new faculty positions were created. Half of those are EECS faculty in computer science and in this new artificial intelligence and decision-making area within the department. And some also in EE, but those are then joint with CS or AI&D. And in fact, we're doing a lot of hiring between different parts of the department and different parts of MIT. And then the other half of these positions are what we call shared faculty. These are faculty who are, whose main home, their sort of tenure home, is a department outside of the college. And they're appointed in that home, plus in EECS or in IDSS, which are the academic units inside the College of Computing that have faculty positions. So they have to have expertise in the discipline, but they also have expertise in EECS or in IDSS. Now, all faculty at MIT and at most institutions are hired in departments, right? So these are not faculty hired directly in the college. They're just, and so because these are hired in departments and all the departments are part of schools, these are faculty in the college and in the schools. So when we go back to these three challenges that I had on the beginning slide there, the rapid growth and advancement of computing, how we address that, how we address infusing computing in other disciplines, and how we address the social and ethical issues in computing. These 50 new positions are aimed at all three of these. So the rapid growth in core CS and AI is the aim of the first 25 positions. Infusing computing in other disciplines is the second 25, and then both sets of those are aimed at the social and ethical issues in computing. We're doing a lot of other hiring as well, and I'll just sort of show you a little bit about the hiring that's happened since the college got started. For these shared faculty, rather than viewing them as 25 unrelated faculty positions across MIT, back in 2020, we did an MIT-wide planning process, 29 departments, put in proposals for how they wanted to think about computing related to their department. So the 6 academic deans, which is the 5 school deans and myself and the provost, reviewed all of those proposals, spent a bunch of time thinking about how to group them together, and came up with a set of areas: social, economic, and ethical implications, computing and natural intelligence, computing in health and life sciences, computing for health of the planet, and computing in human experience. And we've been doing hiring and interviewing in the first 4 of these areas in the last 2 years. And in fact, this year we have a big focus on climate, the computing and health of the planet. So we're doing searches with urban studies and planning, earth, atmospheric and planetary science, mechanical engineering, and nuclear science and engineering, all in the climate area. And climate is a broad focus for MIT generally, not just with computing. So this priority aligns with a big MIT priority. So we made 21 college faculty hires in the last 3 years, sort of 3 in the first year and the other 18 in the last 2 years, so there was a lot of ramping up. The few faculty here that have sort of the blue color under their names, so Connor Coley, Manish Raghavan, Nidhi Sitapati, and Robert Yang are the first 4 faculty that we've hired into these shared positions. So they're based in some department outside of computing, but they do teaching and research in the college as well, and they supervise students in one of the college programs in EECS or IDSS, or operations research, or computational science and engineering. And so this used up 13 of the 50 new college positions, so a little over a quarter of them. But 8 of these people were hired into existing faculty positions at MIT. We're doing recruiting in parallel in the kind of hiring that we would have been doing anyway at MIT in these areas. And so you can see that the college, has done sort of, more than doubled, sort of, kind of 2.5 times overall the amount of recruiting we would have done otherwise. So on the education front, there's a lot to talk about. I just wanted to focus really primarily on the common ground for computing education, because I'm very excited about this initiative. This is, as I mentioned at the beginning, how we're really trying to infuse education with different computing education with different disciplines. So the common ground comes from not only meeting common needs of multiple departments, but also the common perspectives of 2 or more departments or programs. So if you think about, an introductory math class or an introductory computer science class, it meets the needs of lots of departments on campus, but it only reflects the perspectives of either mathematics or of computer science. These classes in the common round bring multiple departmental perspectives together, and I'll illustrate that in a moment. There are 3 areas that we're focusing on: programming and computational thinking, machine learning, AI, data science, and algorithms, as it applies in science, engineering, and social science. So not the stuff that would be taught normally in computer science or AI, and then fundamentals of computational science and engineering. This is an eye chart, and it's not to show anything other than the incredible number of faculty who are involved. This is the planning committee for this, and these faculty are really extensively involved, and they're from departments all across MIT. And this is something that I think is really exciting about the college, is every school is involved, and people from many departments are involved. So we, in 2021 and 21-22 school years, we introduced 4 subjects, and I'll just briefly talk about 2 of them here. And there are several others in development for subsequent years. So one is a computational science and engineering class that's coupled with introductory computer science. So there's sort of a half semester introductory CS class for those of you who know the MIT curriculum 60001, which a huge number of students at MIT already take. And then the computational science and engineering really looks at the modeling, sort of numerical modeling types of questions that come up in something like, landing a Mars lander, which is the illustration here on the bottom. And so the students in this class love it because it's a combination of, mathematics, physics, computer science, aeronautics, all those perspectives brought together in one class. And it is the kind of thing you need to know to do something like design a successful Mars lander. And then linear algebra and optimization brings together mathematics, computer science, operations research. And from the math department's perspective, it covers the same material as the regular linear algebra class. And this is the kind of thing that the Common Ground can do. Some other department could have created a linear algebra and optimization class on their own, but negotiating and navigating multiple departments is very important. If these things don't fill requirements, they can be wonderful classes. Students can't actually take them as part of their degrees. So the modeling with machine learning I wanted to spend another minute or two on just because of its inordinate complexity, but it shows what the Common Ground is able to do. So there's a core machine learning class at the middle here, which teaches about machine learning modeling. And this is very different from a machine learning class normally taught in EECS. A machine learning class for CS or the new AI and D majors would look at really sort of core issues in machine learning. Students outside of EECS, they want to use machine learning as a modeling tool. And so this is a different type of core. But then you can see there are about a half a dozen modules around the outside. And so every student takes the core module and one of these external modules. These other modules are taught by faculty from all of these other departments. And so the amount of coordination in that curriculum to make sure that those things fit together is pretty substantive. And this is, again, the kind of thing that the Common Ground can start to deliver. And this already has hundreds of students in it. So I also wanted to talk a little bit more about CERC. Remember, Common Ground and CERC are the two cross-cutting things in the college that are new and different. CERC focuses on teaching, research, and engagement, although in the sort of hopefully tail end of the COVID era here, there's been a lot less focus on the engagement front in the last 2 years. There are CERC Scholars, which is a broad range of undergraduate and graduate students from all 5 schools who are working on the intersection of technology and consideration of social and ethical responsibilities. And CERC postdocs, who are a mix of full-time and partial postdocs. And they've been really important in integrating CERC material into the research and teaching at MIT. There's also a set of case studies that we have online now that are publicly available. They come out twice a year, a set of sort of 4 or 5 of them in each issue. So there's about 15 of them at this point that we use in instruction here and others are using. And all of the course materials being developed for CERC are available online through OpenCourseWare. And so if you go to OCW and search for CERC, you will find these. The other thing CERC is doing is developing a protocol and an interactive platform that can help researchers consider the social and ethical issues throughout the process of developing their technologies. And this is something that we've also been working on with a number of companies in the development of it. That the social and ethical issues in computing are broader than in CERC. So IDSS has an initiative on combating systemic racism that brings together social scientists and humanists with computer scientists. There's the AI Policy Forum, which is engaging on AI policy issues broadly at a global level. So the OECD is deeply involved, but we are also doing things in DC. And we have a symposium that's on the 19th of May, which is online streaming, open to the general public. And so if you're interested in registering for that, again, your favorite search engine can help you find it, but it's aipolicyforum.mit.edu. And I just wanted to close with a couple of pictures of the new building that's going up on Vassar Street and then take questions. So this is the new Schwarzman College building. This will house both programs that cut across the institute, but also will make space, because if we're hiring 50 new faculty, we need space for 50 new faculty. And that doesn't mean that only new faculty are going in this building. Some new faculty will go in a department somewhere else, but in aggregate, we need space for 50 new faculty. This building is directly adjacent to, so if you look just at the right side there, you can see a little piece of a building. That's 46, where Brain and Cognitive Science is. And so it's right across the street then from Stata Center and from EECS. And then this is just some interior lobby. So the building's right now at the stage of the steel going up. There's a couple 100-seat lecture hall so that we want students to be in the building, not just research. Because of the nature of a lot of interdisciplinary work, there's a lot of collaborative research space in the building. Here you can see EECS in building 38 across the way there. And then there's a great event space up on the top floor that looks out across. You can see the Great Dome and over to Boston by the time you're up on the 8th floor of the building. So with that, thank you very much, and I'm happy to take questions. All right, so I guess they're all online here. So it's not clear how you infuse across disciplines. Can you give examples? So certainly, I'll do this both on the teaching front and on the research front. So on the teaching front, when we look at, and I'll focus for a moment on social and ethical considerations in computing, which really need to be taught from the view of multiple disciplines. So if you take something like a natural language processing class, these are actual examples, and one of the kinds of exercises that NLP class already had in it was getting students to understand what the challenges of labeling training data. So that was already there. So now we have CERC postdocs trained in philosophy or in other humanities disciplines work with the instructor in that class to develop exercises as part of that consider social and ethical issues related to the ways that machine learning labeling is done in training. And so they have an exercise where the students label things, they develop a rubric, and then they swap so that students now critique the labelings of other groups of students, and they critique the actual labeling and variability with respect to the rubric, but also how the rubric took into account social and ethical considerations. So that's an example in teaching. In research, I can give an example of work by Connor Coley in chemical engineering, who's an expert both in machine learning and in chemical engineering, and he's been developing new machine learning methods that are important given the constraints of certain of these design problems that he faces in chemical engineering. And this, on the research front, this is a little bit of an interesting challenge because he has to take the same piece of work and highlight the chemical engineering advances to publish it in the chemical engineering community. But because he's doing really new machine learning, he highlights the machine learning aspects and publishes that in the computer science community. So he has a coherent overall research group that infuses these together, but when it comes to publication, at least as things stand right now, he actually has to publish his work in two communities. The next question here was, what impact have you already seen from pulling together so many efforts related to computing? How do you address concerns about what might be lost regarding autonomy of each program? So I would say that the impact that we're seeing is still very nascent. The college is quite new, but we're seeing tremendous impact in the way students are voting with their feet, in their interest in these brand new common ground classes that integrate multiple perspectives. And also in the kinds of research that's getting done. And it's not just the shared faculty that are doing this broader type of research infusing multiple disciplines, right? This is something that's happening across MIT. And I think the college as a focus on that kind of research has enabled more connections between faculty and different departments in doing that. In terms of autonomy of the programs, which I also think is important, so I'm going to just answer that piece as well. Excuse me. We've been very careful in the college to work with the heads of departments and programs and to do things that are viewed as additive by the programs. And there's nothing that we've done at the college level. EECS is still EECS. CSAIL is still CSAIL. We're not branding anything as the College of Computing other than to say that those units are part of the college. These cross-cutting activities of of CERC and Common Ground are branded as College of Computing because there is no unit at MIT that's doing those. And it's in those activities that we're very careful to make sure that department and lab leadership is very involved in those. And that's why when I showed you that Common Ground steering committee there's a representative from each of the school councils, which is the councils that each of the deans have of their department heads and their lab and institute directors to make sure that we're staying aligned with what's going on in the schools. So this is probably the last one, at least with the countdown clock. So what can business learn from the school in building computational expertise in established professional workforce rather than relying on just new hires? It's a great question. I think that it's easier for us because these are people who are full-time doing their studies. And so as we're developing new programs and we integrate things into those programs, they're learning the integration of disciplines. When you have people who've studied something and you're trying to build their expertise in another area, that is, and especially not on a full-time basis, that is a different kind of challenge. And this is something that we're looking at addressing in the college, but it's very early on now. We have a new activity between the Sloan School and their executive education program and the College of Computing, developing programs. Right now, we're starting just with things that are purely online, and there's a new class on AI and its applications that's taught jointly by Sloan faculty and College of Computing faculty. So one of the key sort of premises of the work that we're doing there in developing those online professional executive education classes is that you want some depth in the technology, but you also really want the business perspective, and that's why everything that will be offered there is a mix of Sloan faculty and computing faculty to make sure that we're doing that. So thank you all for the great questions. It's been a great pleasure and honor to speak with you all here in the room and online today. Thank you very much.